All we need to do is the same thing with slight addition. So if you want to go back to the previous dialog box, and if you want to make some amends, we need to click here on this. Edit last dialog box. We get this. Here there are a few options that we need to select. I'll go to options. That's fine. I'll go to graphs. I want to select all the graphs. I want the individual value plot, box plot of the data. All right, and I'll click on OK. Now when it comes to results, let me see whether all the options are there. Yep, all the options are there. Let me click on comparisons because we are trying to compare the different laboratories. Now this part is important. Here is where you'll have the two-key test. So let me select two-key test. Comparison procedures assuming equal variance. Yep, we have already assumed that the variances are equal, and only because of that we proceeded further. So given that context, I'll use two-key test. You can go with Fisher or the other tests, but for our discussion in this tutorial, we'll restrict to two-key test. Let me click on OK, and once again, error rate for comparison, yeah, 5% significance level. So let me click on OK now. Yeah, too many values, but fine, all this is fine. We will first try to click on this and go to One-Way ANOVA laboratories. Here I want to show you the two key values. So here within the two key pairwise comparison, the average transaction time of laboratory 3 is completely different from laboratory 4. But that average transaction time of lab 1 and 2 are very similar. Average transaction time of lab 1 and 2 is very similar. Now, how do you know that? Because both of these laboratories have the same letter associated with that, BB, meaning this is a different group called A, laboratory 3. Laboratory 4 belongs to a different group called C, and laboratory 1 and 2 belong to a different group called B. So you have A, B and C there, right? So 1 and 2 are the same. That's fine. This is fine. But we can in fact proceed further and discuss about the various plots. So first let us look at the residual plots. Error values, should they be normally distributed? Oh yes, they are normally distributed. And do we have any pattern associated here with respect to residual and fitted values? No, there is no pattern absolutely. You have one lab, two labs, and look at these two labs. These two labs are close to each other. So you see, I mean, you have to very closely look at that. The values of two laboratories are very close to each other. Now what are those two laboratories? It's already given here. It's given here that lab 1 and 2 have very close association. So if you go here, that's lab 1 and 2. This lab 3, this is lab 4, right? And now if you look at the residual histogram, they are also normally distributed. That is what, so everything is normal. There is nothing abnormal about the errors. Now we can go back and look at the interval plot and other plots. If you look at the interval plot, let me hover my mouse there for lab 3. That's the average. And if you look at lab 1 and lab 2, the interval, confidence interval for lab 1 and 2 is almost overlapping. It's almost overlapping, meaning these two are the same. And when you look at the 95% confidence interval for laboratory 3, it's the highest. So the turnaround time is very high. And the turnaround time for laboratory 4 is very low. By looking at the interval plot. You can also look at the individual plot. This also proves the same, right? That lab 1 and 2 have similar kind of turnaround time. Lab 3 has the highest turnaround time and lab 4 has the least. Now when you look at individual value plot, you also get to see outliers if there are any outliers here. I mean, more or less in all the plots you have equal number of outliers maybe. So really considering outliers with extra caution doesn't warrant here. Also you can look at the box plot. If you look at the median, laboratory 1 and 2 have almost the same median values. Lab 3 has the highest, lab 4 has the least. Of course there are a few outliers. Here you have 2 outliers. Here you have 3 outliers in lab 1 and lab 4. Maybe you want to analyze these outliers, retain or remove those based on your outlier analysis, and then maybe you want to perform this exercise once again. But if you look at the middle 50% of the values, we know for a fact that lab 3 turnaround time is high and lab 4 is the least. One more way to assess this is by looking at Tukey 95% confidence interval. Lab 2 minus lab 1. Lab 3 minus lab 1. So let us understand this. Lab 2 minus lab 1 and rest of the things will fall in line. So I'll go here, erase this and mention lab 2 minus lab 1. So you have the average transaction time of lab 2 minus average transaction time of lab 1. And if you look at the Minitab, you have a dotted line which is at 0 exactly. If an interval does not contain 0, the corresponding means are significantly different. So you can say that lab 2 and lab 1 are significantly different if they do not contain a 0. But look at that. Lab 2 minus lab 1 contains this blue dotted line. So within the confidence interval, you have that particular 0 which is falling there. What does that mean? Now, if the average transaction time is 6, here also if the average transaction time is 6, 6 minus 6 is 0. So obviously 0 would be within that. And if there's no huge difference between transaction time of lab 2 and lab 1, obviously the difference between these two would be close to 0. Right? It will be close to 0. So we know for a fact that there is no difference between lab 2 and lab 1. Now let us look at this lab 3 minus lab 1. Lab 3 minus lab 1. Now, if the transaction time of lab 3 is greater than lab 1, you would have all these difference values which will be greater than 0. Think about this. If lab 3 transaction time is higher than lab 1, then how would the scenario be? For example, maybe average transaction time is 8. Here maybe average transaction time is 2. So if lab 3 is greater than lab 1, always the differences will be greater than 0. And if you look at this confidence interval, they're greater than 0. Here is a dotted line which is 0. And lab 3 minus lab 1 is greater than 1. So in comparison to lab 1, lab 3 has high turnaround time. The same implies when you look at lab 2. Lab 3 minus lab 2, right? This also means that the turnaround time of laboratory 3 is greater than 2, right? Laboratory 3 is greater than laboratory 2. So laboratory 3 has high turnaround time in comparison to 1 and 2. That can be inferred. So what does this imply? Laboratory 3 has high turnaround time or greater turnaround time than lab 1 and lab 2. This is one inference. Okay. Now what about lab 4? You have to look at which lab has the highest turnaround time and the least turnaround time. In order to identify that, we have to look at this also. Lab 4 minus lab 3. Okay, let us see this. Lab 4 minus lab 3. Lab 4 minus lab 3. If lab 3 values are greater than lab 4 turnaround time, if lab 3 is greater than lab 4, how would the scenario be? Lab 3 is greater than lab 4. So if this is 8, this will be 6 because lab 3 values are greater than. Then you'll get negative values. So if you look at this confidence interval, there are negative values. It's considering all the values. So it will also consider outliers here. Considering all those values, once again it is proven that lab 3 turnaround time is greater than lab 4. So it's also greater than lab 4. Hence we can conclude that lab 3 has the highest turnaround time. And quickly by looking at this, it should be very clear on which lab is doing a great job. I mean least transaction time or turnaround time rather. So if you look at this, lab 4 minus lab 1 is negative, meaning lab 1 is better than lab 4. Lab 4 minus lab 2 is also negative, which implies lab 2 is better than lab 4. Higher than. Here also lab 1 has higher turnaround time than lab 4. Lab 2 has higher turnaround time than lab 4. Here also it's negative, meaning all these three laboratories, 1, 2 and 3 have higher turnaround time than lab 4. What does that imply? That implies that lab 4 has least turnaround time. Hence proven. Now we know which lab has the least, which lab has the highest. Go back to your management, explain them, and try to take necessary corrective actions. Devise your strategies around this.